doing the integral from 2 to 6 of what function? Which is x. And then what goes next to that x? Dx. And then what has to go out front of this integral if I'm doing the average value?
1 over 4.
1 over what?
4.
1 over what?
4.
Where'd that 4 come from? Where'd that come from? Yeah, so 6 minus 2. So what would this next one be? This would be the integral from 2 to 6, x squared dx 1 over. So it gets pretty repetitive after a while, right? It really should. Average value functions, as long as you know the function, is it pretty straightforward to write these things? At the moment, what's the only way you guys can find the exact answers for these? Calculator. There's actually one of those you could do without a calculator and get the exact answer. Which one? A, yeah, because what is that? That's this function. What's y equals x? Oh, it looks like this, right? And what do you go from? 2 to what? Now, is that something you could find the answer to exactly?
Yeah.
Sure, but what happens when you go to this one? X squared, it's curved, right? If you go from 2 to 6, do you have ways to estimate that? Yeah, and you can estimate pretty well, but you don't have a way of getting an exact answer until you do what? Use your calculator, exactly. Okay, so we were just looking at a graph like this. Velocity, the velocity is increasing, right? So the acceleration is constant, but the acceleration is positive. Write an integral expression that represents the change in distance and evaluate it for the first second and the two seconds. So the area under the curve for velocity gives you the displacement. We've said that many times, right? So if I was going to do if I wanted to know the change in distance for the first second, that would be the integral from what to what? 0 to 1 of v of t dt, right? We're just doing this is just the change in distance. So if I was going to highlight that, what shape is this? What shape does it look like right there? And what's the area of that triangle? 1/2. Yeah, 1/2 1 times 5, I think? Yes. 5 over 2. And what's the next one going to be? Let's do right. It'd be the integral from what? So it's 2 seconds. So 0 to what? Of v of t dt. So we go all the way to here, right? So what's that going to be? What's 1/2 what? 2 times 10, what's that? 10. So all that tells us is, for these first two, in the first second, how far does what's the change in distance? If this was, I don't know, feet per second. This would be 5 over 2. What's the unit on that? It's distance, so it would be what? Feet, and this would be also what? Feet. Do 3 and 4 by yourself. Please do those. Where are they after 1 second? The answer's right there in front of you.
7.5 feet from home.
7 and 7.5. Yes, that's correct. Yes. How did you get 7.5?
Because I just made the fraction of 2.5.
5 plus what?
2.5. 5 over 2.
Yeah, 5 over 2. What about 2 seconds? It'd be 5 plus 10. 5 plus and 5 plus 40. Exactly. The point is, you need to know what your initial position is in order to know where you are if you're only given the velocity. Does that make sense? Do you agree with that? You need that. Okay, sketch a graph, SOT, talk about increasing and decreasing. So we could make something up here. Yeah, we could. We absolutely could. Okay, so let me just pause this here. Let's do that. Here, just notationally, everybody, S of t, S prime of t, what's the rate of change of position called? Velocity, that's right. Good job, everybody. Thank you for the silence. What's v prime of t called? Acceleration. So just notationally, that's what it is. Sorry, everybody, we had just the velocity function, right? And we were going from 0 to what? 1, and then we went from 0 to what? 2, and then to 3, and then to what? 4. If you want to know the displacement on that, this is what this is. This gives you the what? Displacement, right? But if you want to know where the particle actually is, you need to know where it what? Started. So that's going to be the position at the lower, those are called limits of integration. The lower limits of integration. The lower limits of integration. Are you with me so far, everybody? Okay. So let's draw one. Let's just forward and 10 miles backwards. What's my displacement? What's my displacement? If I go 10 miles forward and 10 miles backwards, what's my displacement? 0. This formula should therefore make sense in that category because I would be subtracting 0 minus 0, right? Let's say I started at...
No, wait, but you start at 0, then...
If I start at a place and I end at a place, what's a place minus a place? 0. If I was 5 feet from home and I ended up 5 feet from home, what's my displacement? 0, right? But if I started 5 feet from home, everybody, 5 feet from home, and I did a bunch of stuff, right? A bunch of stuff, but then I ended up 2 feet from home, my starting position was 5, my end position was 7. What's my average velocity? 2. The difference between my final positions, right? This is really helpful. This is super helpful. Here's why. Here's why. Let's say the velocity of a particle is just t. So that would be the velocity of a particle is just t. You could figure out the acceleration. You could figure out the what? The position. Which direction are you most familiar with? Going this way or going down or up? Which one? Down. What's the derivative of t? Come on, you can do it. It's not a trap. 1. Yeah, it's just 1. What's the antiderivative of t?
1 to the t.
1 to the t? I'm asking the question, the derivative of what is just t? The derivative of what is just t? Oh, okay, is it t squared? Yeah. You're close. What's the derivative of t squared? What's the derivative of t squared? Is that what we have? So what should I park out front? 1/2. What's the derivative of 1/2 t squared, everybody? T. There's also something we have to put on this, right? What do we have to say? What do we have to put plus what? Well, could I put 1 there? Yes. Could I put 2 there? 3? 4? Any number. So what we're going to do is we're going to say something like this. C. So this is what we had before. Down below, it told you that the integral from a to b of v of t dt was going to be equal to s of b minus what? S of a. So when we were doing this before, we had that question that was like this. Let's say we had the velocities v of t is equal to t. What was the displacement after 1 second? It was like 5, and then what was it? 10, right? So what was this first displacement right there? 5/2, right? We calculated visually that the integral from 0 to 1 of v of t dt was equal to 5/2. Do you remember that from about 5 minutes ago? Let's go back to here.
It's a little fuzzy.
I know, it's a lot here, but let's go back to this. What I'm asking you now is, let's do it using calculus. From 0 to 1, what was it? It was t dt, right? What is s of t? It's right there. What is it? T squared, right? So we would want it to be s of 1 minus s of what? 0. Okay, what is s of 1? S of 1 is going to be 1/2 what? 1/2 what?
1/2 plus c. 1/2 times 1 squared.
1 squared plus c, right?
Yeah.
Minus what?
1/2 0 squared. No.
Hold on 1 second, everybody. I want 0 going to be.
What? C?
C is just any constant. It's any constant. Just watch what happens. It's gonna be taken care of in a second, Arvin. It's gonna be 1/2 0 squared plus what?
C.
So this is equal to 1/2 plus c, right? And what's this equal to? 0 plus c, right? So we did this out, and we wanted to go from S1. So what was S1? It was what?
1/2.
Plus c. And what was this? Minus? Oh, look, not 1/2. It's 0, right? Plus c. What cancels? They are always going to cancel. And what are you left with? Hey, does that match what we got up there? That seems like overkill for this question. It is, because if you just have a triangle, is it easier to do just a triangle? But here's what it allows us to do exactly. Let's try it out here. Let's say I told you the velocity function was t squared. What's the position function? Raise your hand when you get it. Don't tell me what it is, but tell me, what is the position function if the velocity function is t squared? Cubed, what would live out front?
3.
Do you want the 3 to be there? So you got to take care of it. What do we park out front? 1/3. And you have to say plus c. If I asked you what is the position function, because here's the thing, again, just when you're given the velocity function, do you have any idea what the position is? No. Okay? So what's our time frame? 0 to, what do we want to do? 0 to 5? Is that fine? So let's do, what is the displacement from 0 to 5 of t squared dt? Up until this point, what would we have to use? Now, what are we going to do? We know it's going to be s of 5 minus what? S of 0. Well, in this case, s of 5 is going to be what? 1/3 And this one's going to be s of 0, which is 1/3 0 cubed plus c. Is this always going to be 0, by the way?
No.
No, I can easily make other functions that are not going to be 0. Are you always starting at home when you start a journey? No, it's the same idea. You could start somewhere else, just like in our last example. You could start at 5 instead. So if we do this out, what do you get? What's 5 cubed? 125 over 3 plus c. And what's this one? 0 plus c. So what's this going to be? 125 over 3 plus c minus what? 0 plus c. What's that going to come out to be? On your calculator right now, everybody, do this integral right here on your calculator. Do that integral on your calculator right here. Do that one right there. I'm going to even shade it in obnoxiously just so you can see it real bright like that, okay? Just because I really wanted to color something in right now. There you go. Do that up to what? 4. So you know it's going to be x to the 4th, correct? You know when you take the derivative that that 4 has to drop to the bottom, right? But you want this 2/7 to be there. So keep the 2/7 there, but you want to be able to get rid of the what? Oh, it's 1 over 4. Let's try it again, everybody. I'll go to blue. I like blue. How about 13 over, I don't know, 5x squared? What's the antiderivative of that? Right? You turned it into a 3, but then it also goes there. And now what does that turn into? It turns into 13 over 15x to the 3rd. As you practice this, how quick does it become?
Very quick.
Very, very, very quick. Very quick. Very quick. Okay, ready? Should we make it even more general? What happens if you had a times x to the n, where a and n are constants? What is the antiderivative? Go. No, don't do that. Okay, no. Just realize there are things you can't. So people learn this like, I can integrate anything. I'm like, no, actually, no, you can't.